Hello friends, so in today's question, in the arrangement shown in the figure, mass of blocks A, B, C is 18.5, 8 kg and 1.5 kg respectively. The bottom surface of A is smooth while coefficient of friction between block A and C is mu1 1 by 3 and between B and floor is mu2 1 by 5. System is released from rest at t is equal to 0 and pulleys are light and frictionless. Calculate the accelerations of block A, B and C. So this is a figure. So we have three blocks A, B and C and their mass is given as of A is 18.5, of B is 8 kg and C is given as 1.5. There is no friction between A and the surface, whereas the friction coefficient between A and C is given 1 by 3 and B and surface is given as 1 by 5, and we are going to find out what will be the acceleration of their respective blocks. So first of all, let's drive the constraint relationship between the acceleration of all the three blocks. Okay, so for this, let us draw this block diagram again. So we have a block and it is connected with a pulley to C block, and then there is B block, so this is for A, B and C, and we assume that acceleration block A is moving with acceleration A towards right side, block B is moving with the acceleration of B toward left side, and C is moving downward with acceleration small c. And let T be the tension in the block, in the string rather, T. Okay. So we can use the relationship of, you can say, product of tension and acceleration and try to find out the relationship between A, B and C. Okay, say for acceleration of block A is A, block B is small b, and block C is small c. So let us start from here. The tension for block A is in the same direction as the acceleration, so we can take their product as positive. For B, the tension and the acceleration direction is same, so we can take this as also positive. Their product also is positive. And then on the bottom pulley, once again the direction of tension and acceleration for B is same, so this will be TB, plus for block A the tension, direction and acceleration is same, so this will be TA, and for C the acceleration is in downward direction and tension in upward direction, so this will be minus of TC is equal to 0. So the tension will be removed, so we can say that this C will be equal to 2 times A plus B. So this is the constraint relationship between acceleration of block A, B and C. Now let's draw the free body diagram of block one by one and try to find out all the relative equation for them. So let's try for first of all for block A. So this is A block, and we have a pulley here with a string with a tension T in this direction and T here, and there will be tension here also, and in the downward direction we are going to have MAG, and in the upward direction let us suppose there is normal NA, and because of the presence of block C which is touching A, there is a normal, let us suppose that is N1, and the friction between A and C is present as its coefficient is given mu1. So we can say that there will be a friction, let us suppose call this as FR1. So these are the forces which will be acting on the block A. So we can write the equations. So you can say for block A, let's write it for first of all for vertical side. In vertical direction, we are going to have NA will be equal to MAG plus FR1 and the value of FR1 will be equal to mu1 into N1. So we can say from here FR1 is equal to mu1 into N1. Mu1 is given by 1 by 3, so we can say FR1 will be equal to N1 by 3. And now we can write the equation in the horizontal direction, and it is moving in this direction with the acceleration A. So we can say in horizontal direction you can say there will be two tension, this as well this, so you can say 2T minus normal N1 is equal to M1A, MAA. And let us call this as equation number, this as equation 1, equation 2, and this for block A. Let us do it for block C. For block C, we can draw its block diagram. So block C, there will be tension in upward direction, and we have MCG in the downward direction. There will be normal N1 because of interaction of surfaces, contact surface A and C, and the friction FR1. So we can write, okay, now in this case for C there will be simultaneously two accelerations. First, it will be moving in downward direction with acceleration C, and because of the motion of block A, it will be also moving in this direction with the acceleration A. Okay, so there will be simultaneously horizontal as well as vertical acceleration for block C. So we can say for or in horizontal direction, you can write N1 will be equal to mass of C multiplied by A. Let us call this equation number 3. And in vertical direction, we are going to have mcg minus t and minus fr1 will be equal to mc multiplied by c, and c we already know is twice ab, so here we can put mc to twice a plus b, and we also know fr1, that is n1 by 3, so we can write this equation as mcg minus t minus n1 by 3 is equal to twice mc a plus b. Let us call this equation number 4. Now let's write the equation for block B. So we have block B and it is attached with a pulley. There is a tension T as well as T and pulley here as well. So we have T and this direction T, and it is moving in this direction with acceleration of B, and there is a friction between B and the surface. So there will, let us suppose it is given a friction Fr2, and here there will be mbg and a normal, let us suppose that is nb. So we can say that for vertical, in vertical direction, we have nb is equal to nbg bg, and in horizontal direction we can say there will be two tensions, that is 2t minus fr2 is going to give us mass of p and its acceleration, and we can find out what will be our fr2. Fr2 will be equal to mu2 into nb, and mu2 is given as 1 by 5, so we are going to have Fr2 is 1 by 5 and nb is equal to mbg, so here we can put mbg and we substitute the values. Fr2 is equal to mb is given as 8 kg, is 10 and this is 5, so we can say that our Fr2 is 16 Newton. So we put the value of Fr2 in this equation, so we get 2t minus 16 is equal to b times b. Let us call this equation number 5. Now we have got all the equations. Let us rewrite them again and try to solve it. So first equation which we got is equation number 2, which states that 2t minus n1 is equal to MAA, and we also know that our n1 is MCA, okay, for equation number 3. Okay, n1 is equal to MCA. We substitute the value of n1 in this equation, we get 2t minus MCA is equal to MAA, and this can be further solved as 2T is equal to, taking A as common, this will be equal to MA plus MC. Okay. And we substitute the value, we get 2T is equal to A, mass of A is given as 18.5 and mass of C is 1.5, so we get this as 20A. So from tension T is equal to 10A. Now we are going to use equation 5, which states that 2T minus 16 is equal to MBB. Substitute the value of T and solve it. So we get this as 2 into 10A minus 16, and mass of B we already know is 8 kg. This is 8B. So we get this as 20A minus 8B is equal to 16. We can cut the common things and we are going to get this as 5A minus 2B is equal to 4. Let us call this as equation number 6. Further, we already know that MCG minus T and minus N13 is equal to 2MC A plus B. I think this should be equation number 4. Okay. Now in this equation, we are going to substitute value of N1 as well as T and respective value of mass. So we get this as 1.5 into 10 minus T is given as 10A. So this will be 10A minus N1 is MCA. This will be MCA divided by 3 is equal to twice MC is 1.5 A plus B. So we are going to get this as 15 minus 10A. MC is our 1.5 divided by 3. A is equal to 3 times A plus B. So we can further solve it. We are going to get this as 15 minus, this will be our 10A minus 0.5A is equal to 3A plus 3B. Making the like terms on the same side, we get 15 is equal to 3A plus 10A plus 0.5A plus 3B. So we add them, we get this as 15 is equal to, this will be 13.5A plus 3B, and we already know equation number 6, which gives us 4 is equal to 5A minus 2B. So we multiply this equation by 2 and this equation by 3. We are going to get this 30 is equal to, this will be coming as 27A plus 6B, and this will be 12 is equal to 15A minus 6B. Adding them, 6B cancels out, so this gives us 42 and this will be also 42A. So here A will be coming as 1 meter per second square. we already know the relationship between A and B, so we can use this equation. We can say 4 is equal to 5A minus 2B. Substitute value of A, we get 4 is equal to 5 multiplied 1 minus 2B, or we can say that B will be equal to 0.5 meter per second square. We already know a relationship between A, B and C. C is twice of A plus B, and value of A is 1, so this will be 2, 1 plus 0.5, so this will be coming as C is equal to 3 meter per second square. But okay, once again, this is acceleration of block A, this is acceleration of block B, but for block C, like I said, block C is moving in two directions, in the downward direction with the acceleration C and in the horizontal direction with the acceleration A. So the net acceleration will be somewhere in this direction. So we can say for block C, net acceleration will be equal to A square plus C square, square root. Value of A is 1. Let us call this as C net. A is 1 plus C is 3. This is 9 square root. So we get net acceleration of C, that is C net, is equal to square root of 10 meter per second square. So this is the acceleration of block C. This completes the question. Thank you.